Hello, in this video I'm going to look at the law of sines and a couple of notes to make. First of all, law of sines apply to all triangles, any triangle. So if in most courses you've been studying probably right triangle trigonometry, so that's where of course you have a right angle. But now we can go into any triangle, doesn't matter what it looks like, acute, obtuse, right, doesn't matter. Law of sines, and of course you'll probably learn law of cosines, that applies to all triangles also. Now, the law of sines basically says that an angle and the side it forms is proportional to another angle and the side that it forms within a triangle. Now, oftentimes it's presented this way, when they're all strung together because you have three sides to a triangle, but basically you work with any two at a time. So you might be working with alpha and beta and side A and side B, or you might be working with beta and gamma, and then side B and C. But in any case, because it's a proportion, it doesn't matter if you start with the sine of the angle in the numerator and then the length of the side and then the denominator, or if you work with the reciprocal, so the length of the side in the numerator and the sine of the angle in the denominator. So what I usually do, and make use of this, so whatever the unknown is, I usually put that in the numerator, just to make life easier. Now, what you'll notice is essentially alpha always forms side A, beta always forms side B, and gamma always forms side C. And what that means is, essentially, it doesn't matter what order you write your sides in and your angles. So I could write alpha forms A, beta forms B, gamma forms C, or I could say gamma forms C and beta forms B and alpha forms A. So the configuration doesn't matter, but it absolutely has to be that angle alpha forms side A, angle beta forms side B, and angle gamma forms side C. So you can't switch those out. Okay? Now, when I draw my triangle, I usually don't draw it correctly because you don't know yet what sides you're going to have and how long they are. So I just draw them and then kind of start labeling. But when do you use law of sines? Well, essentially when you know an angle and the length of the side it forms. So you absolutely have to have some angle like alpha and A. That has to happen, that corresponding process has to happen. So it is possible, for example, here's a place where you can't use it. So I can have an angle, let's say alpha, but let's say here I don't know A, but then I know B, for example, is 12 and C is, let's say, 15. In that case, I don't have an angle and its corresponding side. So here I have a side but not its corresponding angle, and a side but not its corresponding angle. So I can't use law of sines there. I also cannot use law of sines when I have, for example, three sides, okay, with no angle. So to use law of sines, you absolutely have to know at least one angle and the length of the corresponding side it forms. Now, so essentially, probably the easiest law of sines problem that you could have is one where you have two angles and a side, and of course where you have to know, of course, the corresponding side with its angle. So let's say, for example, you have, they give you alpha is 40 degrees, beta is 72 degrees, and the length of A is, let's say, 51 meters. Okay, so again, I just draw sort of a generic triangle and I make sure it doesn't look like a right triangle, but that's about it. So when I first start out, I really don't know pretty much anything. So let's say I say alpha is 40 degrees and it forms side A, which is 51 meters. And then I might have beta is 72 degrees, it forms side B, and gamma, I don't know yet, but I can find pretty easily, right? So here's the easiest thing to do, is just basically say, well, all three angles have to add up to 180 degrees. So gamma, what I'm looking for is 180 minus 72 degrees minus 40 degrees, right? Which will leave me with 68 degrees. So now I can say, oh, well, I know gamma must be 68 degrees. Now from there, I can go ahead and say, oh, okay, well now I can say, okay, let's say I'm looking for side B. Now I'm going to put, since that's the unknown, I'm going to put that in the numerator. It makes things easier. So I'm going to say b is to sine of beta as a is to sine of alpha. And now start filling everything in. So b is to sine of 72 degrees as 51 is to sine 40 degrees. And now what I'm going to do is multiply both sides by sine of 72, right? So I'll have b is 51 sine 72 degrees over sine of 40 degrees. Now I'm going to put this in my calculator, and just a couple things to note. When you are working with these problems, these are degrees, so if you were working on something else, you want to make sure you're in degree mode, so go to mode, and make sure here instead of radian, you're in degree mode. And then as I put this in, you absolutely have to have a parentheses after the 72. So what I would do is say 51, and then put in sine 72. Right here, you have to have the parentheses right there to close it. That way the calculator knows, oh, you're done. That's the angle you're taking the sine of. And then divided by sine of 40 degrees. Now here it doesn't matter whether I put that parentheses or not. I'll go ahead and put it, but so what I get is 75 point, let's say 5 degrees. Oh, not degrees, I'm sorry, meters. 75 point, whoop, was 5 meters. That was a length. All right, now that I've got that, I can fill in that and say, oh, well, that's 75.5 meters. All right. And finally, I can find side C gamma. And we're going to do that by saying C is to sine of gamma as, and you really could use the information from B, but because it was a little less precise than I rounded, I'm going to go ahead and use what was given. Okay, so I'm going to use A is to sine of alpha. So I'll have C is to sine of 68 degrees as 51 meters is to sine of 40 degrees. Okay, so I'm saying this angle forms this side as, or I should say this side is formed by this angle as this side is formed by this angle, the sine of that. So there we go. All right, so now we're going to solve for C, and I'm going to multiply both sides by sine of 68. So C equals 51 sine of 68 degrees over sine of 40 degrees. And when you put that in your calculator, you're going to get 73.6 meters. Okay. So here you'll have 73.6 meters. Now that's the easiest case because essentially there's no unknown, there's only one answer. When you subtract the two angles that you know, you get one angle and you just put it in the formula. What's a little bit more difficult is what they call the ambiguous case. Okay, it's called the ambiguous case because you have possibilities. And that's when you have side-side angle. All right, it's the most complex one, and why is that? Well, we'll do an example. In fact, essentially the ambiguous case gives rise to three possibilities when you're dealing with it. You can have no triangle, one triangle, or two triangles. Now, why is that? Well, essentially what happens is when you get to the point that you're solving for sine of an angle equal to a positive number, right, which corresponds to the length of the side of a triangle, which is opposite to theta. Essentially, what happens is the calculator will give you something in here because it's a positive number, so you're looking for a y-coordinate of this length, and it'll give you some angle, right? But sine, remember, this question that you're asking is for what angle is the y-coordinate, this positive length? Well, there's another answer here in quadrant 2 somewhere, which is a reflection here. So here's another possibility. And that's another angle. And since both of these angles are less than 180 degrees, and the sum of all three angles in a triangle has to be 180 degrees, sometimes it's possible to have one triangle or two triangles or no triangles. That's what ends up happening. So let's take a look at an example then. And we're going to go through each of these and in this order. When no triangle arises, when one triangle arises, and when two triangles arise. Okay? All right, so for the first example then, where you'll end up with no triangle, we'll have, let's say, alpha you're given is 102 degrees, A is 7, let's say, feet, and B is 9 feet. Okay? So again, I draw my little generic triangle, and I say, okay, let's see here. Alpha is 102 degrees, and it's across from A, which is 7 feet. And then beta here I don't know, and gamma here I don't know. What I do know is B is 9 feet, and I don't know what C is. All right, so when I start out then, I obviously have to work with this, the angle and its corresponding side. And then let's say, since I know the length of this side, I'm going to try to find this angle right here, beta. So I'm going to set up sine of beta is to the length B, as sine of alpha is to the length A. Now let's start filling everything in. You'll have sine of beta is to 9 as sine of 102 degrees is to 7. Now again here, I'm going to multiply both sides by 9, so I'll have sine of beta is 9 sine of 102 degrees divided by 7. And so sine of beta, when you put all this in, you're going to get 1.2576. And you're like, wait a second, you're asking the question, for what angle is the y-coordinate a length of 1.2576? And you know sine never exceeds 1, so you're like, ah, no possibility. So that's where no triangle arises. Excuse me. So then let's take a look at where one triangle arises. So that could be alpha is 110 degrees, A is 19 feet, and B is 8 feet. So again, I draw my little triangle here, and I may have alpha is 110 degrees, beta is, do I know yet? No, don't know, and gamma I don't know. So what I do know is I have 19 feet here, and then B across from beta is 8 feet. So that's what I know so far. So I'm going to go ahead and set up sine of beta is to B as sine of alpha is to A. So we have sine of beta is to 8 as sine of 110 is to 19. So again, trying to isolate beta, so I'm going to multiply both sides by 8. So I'll have sine of beta is 8 sine of 110 degrees over 19. And so you'll get sine of beta is 0.3957. Now again, this is asking for what angle is the y-coordinate a length of positive 0.3957. Your calculator is going to give you that beta is 23.3 degrees, all right? But it's not going to give you the other possibility. So what I do is immediately set up two cases. And the reason I do that is because it's so easy to work one case and then forget the other. So what we know is, in case 1, we're going to say beta is the 23.3 degrees, right? So that means gamma is 180 minus 110 minus 23.3 degrees, so gamma is 46.7 degrees. So that's a possibility that could give rise, that will give rise to a second triangle. In case 2, we have to consider that, well, okay, if at 23 degrees, right, 0.3 degrees, the length of the y-coordinate is 0.3957, where else is, for what other angle is the y-coordinate a length of 0.3957, and that would be symmetrically over here, so that's going to be 180 degrees minus 23.3 degrees, right? So that's going to give us 156.7. So this is this case. This is the case where beta is 156.7. And of course, when you look at that, you're like, well, wait a second. That would mean that gamma would be 180 minus 110 minus 156.7. which would end up giving me a negative 86.7 degrees, which is what? Not possible. So I know this second case is not going to be possible, and therefore I only have one triangle, okay? So we proceed then with this one just to figure it all out and say, okay, if beta is 23.3 degrees, right, that's what I'll have here. Let me go ahead then and figure out, we already figured out gamma, so we then just have to figure out C. So we figured out gamma was 46.7, so now we're going to go ahead and set up a ratio to solve for C. So we're going to say C is to sine of gamma as, and again, we figured out 23.3 degrees for B, and we know it's 8 across from 8 feet. But I like to go ahead and work with what I was given that's more precise, so I'm going to use A is to sine of alpha. But you really could use either one. So then we're going to go ahead and fill everything in. So we have C is to sine of 46.7 degrees here, as A, which is 19 feet, is to sine 110 degrees. So here we have alpha, alpha is to A, as gamma, which we now know is, in this case, gamma is 46.7 degrees. All right. This gamma is to C. So that's what I'm setting up. And so now I'm going to solve for C. C is 19 sine of 46.7 degrees over sine 110 degrees. And then when you put that in your calculator, you're going to get 14.7 feet. Okay. So here then we have C is 14.7 feet. Okay. So that's solving the ambiguous case where there's one triangle, and we realized when we went to go figure out the other possibility for the case 2, the angle was too large so that the sum of the three angles exceeded 180 degrees. So we knew we couldn't have that possibility. All right, the last possibility is when we have two triangles. And let's go through that one. So the example for two triangles. Oops. Two triangles. All right, so that's where A is 12 feet, B is 15 feet, and alpha is 52 degrees. Okay. So again, generically, I just kind of write, just so I visually can see it. So I have alpha is 52 degrees across from A, which is 12 feet, and then beta, we don't know. Gamma, we don't know either, but we know across from B is 15 feet. Right? And we know nothing else. We don't know C. All right, so we're setting up our ratio to solve for beta. When we say sine of beta is to B, as sine of alpha is to A. Start filling it in. So sine of beta is to 15 as sine of 52 degrees is to 12 feet, right? So again, multiplying both sides by 15, I'll get sine of beta equals 15 sine of 52 degrees over 12, which means sine of beta is 0.9850. Now, in solving this, we're going to ask the question then, let me write that up here, sine of beta is 0.9850. So in solving that, we ask the question, for what angle is the y-coordinate a length of positive 0.9850? And of course, you've got two possibilities. And your calculator will return, like say over here, right, will return this value, and it'll be 80.1 degrees, which is the inverse sine 0.9850, in degree mode, by the way. So then where else do you have, for what angle is the y-coordinate a length of 0.9850? Well, it's 180 degrees minus this 80.1 degrees, and you'll see that's going to be 99.9 degrees. Okay, so that gives rise to two cases. So you have case 1. Oops. Case 1 versus case 2. You have here beta is 80.1 degrees versus beta is 99.9 degrees. Okay. So when you do solve for your last angle, right, you know alpha's 52, so you'd say, well, okay, if beta is 80.1, I'd have 180 minus 52 minus 80.1 degrees, and that's going to give me gamma is 47.9 degrees. Okay, and let's take a look at this case just so you can see that it should come out. So here it's 180 degrees minus your alpha, which is 52 degrees, right? Minus now your beta for this case is 99.9 degrees. And gamma comes out to be 28.1 degrees. So it is possible for the sum of alpha, beta, and gamma to be 180 degrees, case 1, and for alpha, beta, and gamma to be 180 degrees in case 2. So you've got two triangles that are possible. Okay? So now you keep going, and you're going to go ahead, now that we've solved for pretty much everything except for side C, we're going to solve for side C for both of these. So C is to sine of gamma as A is to sine of alpha. So here C is to sine of 47.9 degrees as 12. Let me just show you this part. Alpha is to 12, right? And now we're doing gamma is to C. As 12 is to sine of 52 degrees. Okay. And we're really setting up the same thing over here. We're going to do the same thing and say C is to sine of gamma as A is to sine of alpha, but with just different numbers. Here we're going to have C is to sine of 28.1 degrees as 12 is to sine 52 degrees. So you see what we're doing here. Now I'll go ahead and finish this and then finish that. So we'll have C is 12 sine of 47.9 degrees over sine of 52 degrees. Okay. And then you'll get C here is 11.3 feet. Okay. Versus here you'll have C equals 12 sine 28.1 degrees over sine 52 degrees. So here C is going to be 7.2 feet. Okay. So those are your two different triangles. We got all the lengths. And let me see if I can draw you pictures, see what that looks like. So for case 1, what you had is something more like alpha is 52 degrees, beta is 80.1 degrees, and gamma is 47.9 degrees. And here you had 12 feet, 15 feet, and then 11.3 feet. Versus case 2, and I'll show you those calculations again, but you have something more like this, where you have alpha is 52 degrees, beta is 99.9 degrees, right? And here you have gamma is 28.1 degrees, right? It's a small angle. And so across from it is the small side, 7.2 feet. And across from alpha is 12 feet. And across from beta is B at 15 feet. Right, so you have two different configurations. So you had case 1, case 2. You can look over those numbers. Where the original one, you were told basically alpha is 52, A is 12, and you were told B is 15. Okay, so those are your two configurations. And then what books will do is sometimes draw this so that, like, essentially you've got, well, if you could have something like this length, and it basically can meet over here. Right? It meets over here, or it meets over here. All right. Thanks so much for listening.